If you could use your mics, that would be better. So, 혹시 그 CT 트레이닝 끝나고 나서 그 미믹3 액세스 하는데 얼마나 걸린다고, 2주 걸린다고 뭐 이런 얘기 들으신 분 있으신가요? 아니 분명히 내가 그런 이메일을 봤는데. 혹시 미믹3 액세스 지금 받으신 분 계신가요? Is there anyone who has access to 미믹3? 이벤트 메일의 최대 컨펌 2주. 하지만 다 액세스 신청은 하신 거죠? 신청 안 하신 분 계신가요? 액세스 신청 안 하신 분 계시면 알려주세요. Is there anyone who didn't request for access to Mimic3? 네, 없으신 걸로 알겠습니다. 강준이, 네, 알겠습니다. 그러면은 그 강준이님 빼고 그 다른 분들께는 제가 그 직접 받아가지고 공유를 할게요. Mimic3를 저는 지금 받을 수 있거든요. 그러니까 they said it may take a week or longer to process your request. Thank you for your understanding. 옛날에 안 그랬거든요. 한 3일? 3일 많아 이틀? 이틀 3일이면 됐는데 되게 뭔가 좀 바뀌었나 보네요. So it used to take maximum 3 days or so, like in the past when I was requesting access, like a couple years ago, or maybe 4 or 5 years ago. I think maybe the system has changed a bit. So what I'm going to do is I'm going to download the CSV files and then share it with you via Dropbox, so that you don't have to wait for 2 weeks to do anything interesting. And I can only give it to people who has city certificate and who has requested access to Mimic3, because this is like I'm giving you access in advance because you've already gone through the city training, you have already requested access, so I'm just giving it to you in advance. So that won't be like too problematic. So 그 제가 한 말 다시 반복하자면은 미리 시티 트레이닝 하시고 그 다음에 그 미믹3 신청하신 분들한테는 제가 직접 미리 다운 받아서 CSV 파일을 제가 그냥 그 드랍박스 통해서 공유를 할 테니까 그거 받아가지고 그 앞으로 다음 주에 나올 숙제 하시면 될 거예요. 네, 잠깐만. Let me take a look if I have all the files on my local hard drive. Okay, I only have 10 files, so I need to download at least like 15 more. So I'll do that. After this class, I'll download all the files from the Mimic3 website, and then I'll share it with everybody. Do I have email with everybody? Okay, so I do have email address for all the Naver engineers and all the students except for 2 people, Paco, Ran, and Kim Dongjun. I don't think they are here today. Okay, so after I download all the Mimic CSV files after this class, I will upload the link to my Dropbox on Classum and KLMS so that everybody can see where everybody has access to the link, and then they can download the CSV files themselves. 제가 이 수업 끝나고 클라썸이랑 KLMS에다가 올려놓을 테니까 그 주소를 제 드랍박스 링크를 그거 보고 다운받으시면 될 것 같아요. 네, 그러면 it must be related to the COVID situation. Enforcing closure of non-essential, what? They've been enforcing closure of non-essential businesses. So I guess they're only giving access to like immediately like research projects that immediately need requests immediately needs access to Mimic3 then. So okay, that's understandable. We can forget about that. So they'll give you access in time eventually, so no matter. Okay, so all right, so then we will do that, and so hopefully I expect everybody to have the CSV files on their local hard drive so that we can go through some demos on Thursday. And today I'll just go ahead with the demo on my own, and then I'll give you a brief overview of the structure of Mimic3 dataset, because if you're new to the EHR, it might seem a bit too complicated, but it's not. So I'll give you an overview and the coding system of Mimic3 and how the most representative example of what people do with Mimic3, which is mortality prediction. So we'll talk about that today. And then on Thursday, we'll go ahead with demos. You guys can go ahead and do a little demo on your own, and then we'll proceed to the next, which is how to model the EHR data with neural networks. All right, so let me share my screen. Okay, give me a second. Need to open the file. I'll just go ahead and open the desktop. Okay. All right, can everybody see the slide which says de-identification? If anybody has a problem seeing my screen, my shared screen, please raise your hand or type it in the chat box. All right. Okay, I guess we can go ahead then. Okay, so all good. Okay, so wait, how do I close this? Put it here, put it here. All right. Okay, so okay, thanks everybody for going through the city training and requesting access to Mimic3. I'm very sure that the city training wasn't very fun, but it's something that we have to go through at least once. And the good thing about city training is after you've done this once, you can request access to some other data sets that the MIT people have open source, which is Mimic3 time series data. Oh, actually, I didn't. We can talk about that later. So there's Mimic3, the electronic health records, but there's also Mimic3 time series data, which is the sensor readings of the ICU patients. As I said, when you go to the intensive care unit, you get hooked up to a lot of devices, a lot of like sensors and like monitors and stuff, and then you get like a lot of like readings from your body all the time. And then that readings are basically a time series. For example, if the device measures your blood pressure every minute or every 5 minutes or every 10 minutes, that basically becomes a time series data. And then, I don't think I think Mimic3 has blood pressure, but some other data sets such as like EKG, like you hook up some devices to measure the heart rate and the like how the electricity basically flows through your body through via your heart, and that's EKG. And some that I don't think the Mimic3 EHR contains EKG readings, but the Mimic3 time series dataset has EKG readings. So it's a separate dataset, but you can still request access to this time series data with the same city completion report. So you can do that with one city training. You can have access to a lot of different types of health records. So as we proceed with classes and you some of you might be interested in doing your so there's project, which is just free topic. You can do whatever you want. After I've given you basic steps on how to pre-process EHR, how to do modeling, how to predict stuff. I'll give you, so that's basically what I'm going to teach you over the first half of this course. And then the next half would be basically just doing project and looking for very interesting applications or recent popular papers and that kind of stuff. So once we've covered the basic groundwork, and some of you might become interested in time series data, and then you might be able to because you have city training, city certificate, you can request access to the same time series data and do projects on top of that. So 예. 요약하자면은 CT certificate CT 트레이닝 한 번 해두시면 그거 가지고 미믹3 요청하듯이 다른 데이터셋 요청할 수 있으니까 계속 가지고 계세요. 그거 지워버리거나 그러시면 안 됩니다. 네. 그리고 방금 말씀드렸듯이 미믹3 말고 이제 타임 시리즈가 따로 있거든요. 미믹3 타임 시리즈가 따로 있는데 그게 이제 심전도 검사나 이런 거 결과가 이제 이렇게 몇 초에 한 번 아니면 몇 번에 한 번 이렇게 샘플링 돼서 이렇게 타임 시리즈로 나타나는데 그거에 관심 있으신 분은 나중에 타임 시리즈 데이터를 다운받아야 되니까 그때 CT certificate 한 번 더 쓰게 되실 거예요. And besides from the Mimic3 time series data, there's also a data set called EICU, which is relatively new. So let me actually show you what it is. So EICU is also a data set open sourced by MIT people. So it's the same group of people who open sourced Mimic3. They have collaborated with Philips. I remember seeing the name Philips somewhere. Overview. Yes, it's a Philips EICU program. So yeah, so it's called Icu Collaborative Database. It's a collection of tables relating to patients who are treated as part of the Philips EICU program across intensive care units in the United States. So this is different from the Mimic3 because Mimic3 is basically a bunch of ICU records coming from the Beth Israel Deaconess Hospital, which is in Boston, as I've shown you in the last class. They're right across the river of Boston. So like MIT is on the north side, Beth Israel is on the south side, and then they collaborated and then they open sourced ICU records. This one, EICU, is open sourced by the MIT people, but under the collaboration with Philips, which is an electronics company. So you guys probably know Philips with their electronic toothbrush and stuff. So Philips is in the healthcare business, because I know a former acquaintance of mine who has worked in Philips and reached out to me for their healthcare department, like using how to use electronic health records with neural networks. So they definitely have healthcare department. And EICU program is basically I haven't gone through their brochures, or I haven't gone through their website, but basically it's a remote ICU caretaking solution. So people who have gone through ICU or people who are in ICU, sometimes they need remote caretakers. So because maybe they don't have any family or friends, or maybe they have contagious condition. So people need to monitor their situation, the patient situation, remotely from I don't know, if a person's mother is in ICU and the son cannot be there all the time, then maybe they can do it remotely using web-based service, web platform, or whatever. So I think EICU is the thing that enables that kind of technology. And so this is coming from all across the United States, because it's a remote solution. So it is installed in a lot of different hospitals or ICUs across the United States. So it's in some sense it's better than Mimic3, because first of all it's larger. So it has about 200,000 patient records, which compared to 50,000 in Mimic3, it's 4 times larger. And it is from multi-site. It's a multi-site data set because it's coming from a lot of different locations in the United States. So it is more diverse in terms of the patient quality. So it doesn't consist of patients only living in the Boston. This is coming from all across United States. So if people are interested in multi-site research, like maybe some people want to analyze like the quality of the outcome from one hospital to another, like if some of you are interested in that, then you might want to have access to EICU down the line. And again, the same requirement, requesting access, you still need to go through city data or specimens only research. So you already have done that. So you have that, you just request the access to this EICU dataset through PhysioNet, which is the same procedure. Maybe it will take you a couple of weeks, just like Mimic3. But anyway, so a lot of interesting data on PhysioNet. So keep your city completion report. Don't delete it and go through city training again. Yeah, even if you delete it accidentally, I think city program here will keep track. Will probably retain the records that you've completed this which one, the data or specimens only research course. So I don't think that will matter, but still, like don't delete it. Okay, so just to summarize in Korean, EICU 방금 전에 영어로 말씀드렸는데 한 번만 더 말씀드리자면 EICU는 이 미믹3랑 다르게 이제 미믹3는 베스 이스라엘 하스피탈이라고 해서 이제 보스턴에 있는 병원의 데이터만 가지고 만든 데이터셋이에요, 미믹3는. 그래서 환자 수도 이제 5만 개로 적고 그 환자도 전부 다 보스턴에 사는 사람만 데리고 하고 있거든요. 근데 이 EICU는 이제 필립스가 이 원격 그 중환자실 모니터 솔루션 같은 거 납품하면서 그 이렇게 컬렉션한 데이터셋이래 가지고 이거는 이제 미국 전역에서 그 컬렉션한 데이터예요. 그러니까 보스턴에 있는 게 한정된 게 아니라 미국 전역에 뿌려진 꽤 훨씬 더 많은 4배 정도 되는 20몇만 명 정도의 데이터 그 환자 수를 가지고 이제 만든 데이터셋이라서 훨씬 더 크고 훨씬 더 다양하고 또 그 로케이션 다양해서 나중에 뭐 예를 들어서 뭐 어떤 지역은 뭐 어떤 병이 많이 걸린다, 어떤 지역은 뭐 다른 병이 많이 걸린다, 이런 거 분석하시고 싶은 분들은 이제 EICU 데이터셋을 하셔야 돼요. 이 미믹3로는 그런 걸 할 수가 없으니까. 네, 그거 말씀드릴게요. 네, 그 다음에 okay, moving on. So okay, so that's the like a collection of data set that you can access. Now we should talk about the identification because this is something called PHI dataset, which is protected health information. So Mimic3 or EIC or any health records are all PHI. They contain protected health information, which means that they like your names and it's especially health information, like what you've had, like what you suffered from, like what kind of medications you're taking. That kind of information is all in Mimic3 or EICU or time series. As long as it's health records, it is there. So raw EHR meaning that the data set the hospital actually has in their database. Raw EHR holds protected health information. So basically they know the hospital knows your name, your date of birth, your gender, they even have take the picture of you. So they have your picture, so they exactly know who you are, and they know your medical history, what you've gone through, and your family history even. Like basically they know your life. So it's very sensitive information. And we do not want to share our health info to an unknown party. So we don't want hospitals to go about their way and share their data with the government, for example, but not just the government. Maybe, for example, let's imagine that Assam Medical Center, for example, can sharing like thousands, maybe millions of patient records with Samsung Research and Samsung electronics company. Then they probably can use that information to screen their candidates when they're hiring their employees. Like they don't. So companies in Korea as well as companies in the United States, they support healthcare to their employees, and because of that, that's a cost. They're losing money if one of their employees uses healthcare a lot, and so that's why some companies don't want to hire people with disabilities or people with potentially very risky disease. Like if if I run a company and I try to hire like employees, and maybe I can go, maybe I have access to their medical records, and if I see that one person is about to have heart failure within a year or two, I'm not gonna hire that. I'm not gonna hire that person, because hiring that person is a liability to me, because it's gonna cost me a lot with respect to healthcare. So that's like that's like a very very representative scenario when your protected health information is leaked to the external party outside the hospital. That's how your information might be used. So we don't want that to happen. So de-identification is what prevents that from happening. So according to the law of Korea, or it's the same. According to the law of United States, de-identification is required in order to share hospital records to researchers or maybe even companies. I don't think that's still allowed. Like sharing your personal health records to a company to generate revenue, I don't think that's very doable either in United States or Korea. It's mostly for research. Because when you go to a hospital and then you sign a bunch of forms when you are first admitted to the hospital, and one of the clauses in the form is that you consent, you basically agree to the use of your data for the purpose of research. That's always in one of those forms. So in Korean, to summarize, 그 병원 가실 때마다 이제 그 처음에 입원하실 때 뭐 아니면 뭐 하실 때 이렇게 뭐 여러 가지 사인 하시잖아요. 거기에 보면 항상 그 조항이 있어요. 당신의 그 병원 기록을 우리가 연구용으로 사용할 수 있다라는 그거가 있거든요. 그러니까 병원에 가시면 자동으로 그걸 항상 체크를 하셔야 해요. 그거를 벗어날 방법은 뭐 변호사를 대동하시든지 뭐 그런 방법도 있기 때문에. 그래서 이제 기본적으로 저희가 병원에 가서 생성하는 데이터는 전부 다 그 병원이 연구 목적으로 사용할 수가 있어요. 그거는 무제한이에요. 그래서 병원 내에 계시는 의사 선생님들은 언제나 우리 데이터를 가지고 연구를 하고 계세요. 그게 당연히 필요한 거고. 근데 이제 그거를 돈을 벌기 위해서 다른 뭐 예를 들어서 카카오톡이나 네이버나 아니면 뭐 이런 데다가 돈을 벌려고 데이터를 주는 거는 굉장히 한국에서는 불가능했고, 데이터 3법 이전까지는 미국에서도 굉장히 힘든 걸로 알고 있어요. 그걸로 돈을 번다는 거는. 그래서 미국은 한국은 아직까지 법이 마련이 안 돼서 그런 거고, 미국은 이제 특히나 뭐 프라이버시 막 그 정부가 막 이렇게 사람한테 관여하고 그런 거 굉장히 싫어하기 때문에 이제 그런 게 굉장히 막혀 있습니다. 굉장히 철저해요. 그래서 뭐 히파라는 룰도 있고, 아마 뭐 시티 트레이닝 하시다 보면 뭐 보셨을 텐데, 이제 히파라는 게 뭐 옛날에 뭐 70년대인가 뭐 80년대 생겨가지고 그거 가지고 이제 모든 그 비즈니스 오퍼레이션을 합니다. So as I said, there's a law called Hipaa, which is HIPAA in United States, which was established maybe back in the 70s or 80s, that lays the ground rule for how to share your health records to different parties other than hospitals. So within the hospital, de-identification is not required. Within the hospital, they can use your data as in any form, any way possible, is as they like or as they see fit. So that's okay. But if the hospital wants to share your record to a research company or academia, like to myself, or maybe the government wants to do like statistical research, statistical analysis on the patient record, then they need to de-identify the patient record so that the third party, the one that receives the health records from the hospital for research, the third party cannot pinpoint the identity of a single person from the received data set. So that's what de-identification procedure is. So EHR de-identification consists of mainly, there's a lot of techniques that go through. Maybe I think the statisticians or some IT healthcare experts or IT engineers, they came together and then like set the techniques how to de-identify EHR. But basically they remove all names, because obviously if you see names, then there's a very high chance you can pinpoint the person. So they remove all names, and they remove not all, but like very granular location. Maybe they can retain the zip code, like the 길거리 주소, which is, so they may retain the zip code, but they remove all like the apartment number, the house numbers, and all that. And they remove, again, this is kind of interesting statistical property, but if somebody has a very rare disease and they share your data, even with your names and locations removed, they still might be able to pinpoint who you are. Like they might identify who you are. For example, very rare cases, if I have a disease which is so rare that only like 10 people in Korea have the same disease, and then like if the hospital shares my data, and then anybody who knows that I have that disease might be able to identify my record in the shared data, because it's a very rare disease. Only 10 people in Korea have that. So if you combine different kinds of information like the zip code and the age, the date of birth, and the condition that I have, then they might be able to say like, hey, that row, that patient, that anonymous patient seems like the person that I know. Like Edward has that condition, so oh, he is in that data set. So we don't want that to happen. So that is why we remove all rare cases. For example, people over the age of 90 years old. There's very few people in Korea who's over the age of 90 years old. So if you include their information into the data set and you share that with a research institute, they might be able to tell who they are. Like, I know a person who's like 95 and this person looks like that person. Like, we don't want that to happen. So so remove like very, very old people, very rare diseases, like all that. So, and then another thing that typically happens is they shift the dates of patients or all events basically. So they shift the date. Like if my date of birth is like 1964, like June 12th, they shifted like 100 years later or 150 years later, so that like a birthday. I mean, birthday is not very unique. It's not as unique as rare diseases or being over 90 years of age. But still, like if you combine different mode of information, like date of birth with some disease and some like basic location information, some marriage information, if you start combining a lot of information, then there's a very high chance that you can still identify a patient in your data set. So in order to like minimize that from happening, that is why we take a lot of measures. Okay, so there's a chat. Does remove rare cases mean remove whole records from the patient or just hiding those rare? Wow, we mean that we remove the whole records from the patient. So any patient who's over the age of 90, we just remove the patient entirely from the data set. If anybody has like very rare disease, we just remove their data set from the remove their entire patient record from the data sets, which is kind of a loss in terms of research, because sometimes we want to do research on rare cases, or sometimes we want to do research on very old people. And because of this de-identification issue, if the hospital just removes them completely and then give the data set to us, then there's no way we can conduct research on rare diseases. So it's a problem. I'm sorry. But basically there's no real good way to deal with, like, to satisfy all the needs for different, like all the needs of different parties. So there's always like there's a lot of players in healthcare research. There's doctors, there's hospital, there's researchers themselves, and then there's patients, and then there's non-government entities like 시민단체, like citizens groups, who always like voice their opinions very, very loudly. So it's very, very hard to satisfy everybody's requirements. So something we have to just sacrifice. All right. Okay, so typically what they do with dates is they shift the dates into completely like unidentifiable future. But what they typically do is they shift all the events of that particular person in the same amount. Like if the person, like if you shift the date of birth of person A by 150 years, then you shift everything that happened to the patient by 150 years, so that they preserve the internal consistency. For example, if I was admitted for 2 days in the hospital, then that same information needs to be retained in the de-identified version as well. So both raw data and DID data needs to hold the same like temporal information, even after the shift. So you need to shift the dates very carefully, and they usually it depends on the data set. Some data sets, for example, what they do is I've once had access to the Brazilian data set. Brazil is a very weird country. They open source all their patient records. Like, I think they have the same central insurance, just like the Korean version. Like United States have like compartmentalized insurance schemes. So there's very limited central insurance only for the old people or only for the poor people, like Obamacare. But in Korea, everybody has insurance. So it's just the same, probably in Brazil. Everybody has insurance. And the Brazilian government actually open source a big portion of electronic health records online. And I tried to access it once, and I realized that how they shift dates is they don't shift dates, but what they do is they remove the date information. So they retain the month, so they retain the year and month information, but they delete all the date information. So which to me is kind of like useless. Like, I don't think removing all the dates is very helpful for like time series analysis or longitudinal EHR analysis, that kind of stuff. So basically, there are a lot of ways you can like mask the temporal information. You can either shift the dates, or you can just remove the dates or the hours or something like that. In Mimic 3, they just shift the dates, and they don't remove any like dates or hours or minutes, which is very good. And how they shift the dates is there are a certain number of rules. First of all, they preserve the time of day. So when they shift the dates, they don't shift the hours. The hours are the same. It's just that the dates are shifted, and the day of week is also preserved. So if something happened on Monday and you shift the dates into like 150 years later, it still needs to be the Monday. Like Mondays, Tuesday, Saturday, Wednesday, Thursday, like that needs to be retained even after the shift. And seasonality also needs to be retained. So if something happened in the summer, then after you shift the dates by 150 years, you still want that the DID thing also also happening in the summer. So like there are a certain number of conditions that the Mimic 3 people like very carefully designed how they want to shift the dates. They want to shift the dates as randomly as possible, because if you just shift by 150 years for everybody, like if you just shift all the patients by 150 years, that doesn't really mean anything. You just need to minus 150 years back, and then you have the real like dates, so you can start like trying to re-identify patients. But so what you want to do is you want to randomly shift the patients. Like some patient you shift by 150 days, 3 months and 5 days, something like that. And some other patient you want to shift by 162 years, 6 months and 12 days. But as random as you get, there are a certain number of conditions that you have to preserve, like time of day of week, seasonality, that needs to be retained. So like shifting doesn't prevent you from doing meaningful research. So these are 4 techniques that usually go into the identification process. Does anybody need any explanation here, or does anybody want me to repeat what I said in Korean? Any question? Okay, no. All right. Okay, we'll proceed then. So when I very 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 important. So the whole reason that I'm talking about the identification is, well, one reason is because it is just how you need to understand how Mimic 3 is created. But another thing is privacy is a very very important issue, and when you have access to Mimic 3, you should never ever share Mimic 3 with a person who hasn't gone through CD training and who hasn't like requested access to Mimic3. It's for your research only, and by law, you should never share the data with even your family or friends. I mean, that's the law. I mean, nobody's like, it's not gonna, like, the United States police is gonna come to Korea and then, like, take you to prison or anything. It's not, but basically, but still, like, that's how the ground rule is. Even if the data is de-identified, it's still for your research purposes only. It's like individual by individual. So never share the data. Even so, the reason that I'm sharing the data with you is because you've all gone through city training. You've all gone through the request access request, and eventually you're gonna get access. So I'm just gonna do it in advance. But you should never do that with other people. So don't do that. Or like, if you get in trouble, it's gonna be in serious trouble. And for preserved day of week seasonal rule example case. Oh yeah, so I'm not exactly sure if this meets the requirement for this. I guess it depends on the actual implementation of the shifting. Maybe the IT engineers who created Mimic3, maybe they thought June and August is still the same summer, so they might have shifted. Like, this might have happened, but so I can't really be sure if this should be like, if 06 should be the same as 06 here. Yeah, I'm just repeating what they say in the official website. They say the seasonality is preserved. So this is just my estimation. If seasonality is preserved, then maybe this happened. So yeah, I mean, it would be better if they actually retained the month as well, but they said they didn't retain them. They didn't preserve the month. They just preserved the seasonality. And by seasonality, I'm not sure what they mean by seasonality. Maybe, I'm not sure if like October and December is in the same season, or maybe October and January is in the same season. I don't know how they did that. So, but yeah, but basically what they're saying is they didn't destroy the temporal information too much. Yeah. Okay. So, what was I saying? As I was saying, identification. Yeah, the gist of it is don't share Mimic3 data with other people. All right. And as there are some people who, if somebody's really interested in de-identification, there's research going in that line, like how to best de-identify EHR without destroying too much information. And there's, for example, structured information is kind of easy to de-identify. Like, so as I said, EHR is stored in a relational database, and if you know the structure of the database, it's kind of relatively straightforward how to de-identify relational database. You know the columns and you know what they represent, so you can like write a program to de-identify the entire RDB, the relational database. You can, like, if the column has like names, then you just remove that column. If the column has like dates, then you randomly shift all the like time related column by the same amount. Like, you can write a certain program to do that. But if we're talking about clinical notes has a lot of differently nuanced health information. Basically, for example, notes usually has names in the notes. Like, for example, if you go to a hospital and the doctor says like, Edward is suffering from stomach ache, and his stomach ache hasn't recovered since like last month or whatever. Like, they describe, doctors or the nurses describe you in a variety of ways, and it's very hard to like airtightly de-identify notes. That's why notes are usually not shared to researchers. It's a different level of privacy risk. The hospitals are okay sharing structured data most of the time. Well, I mean, if they see value in research, but they're very, very careful about sharing notes, and it's usually they just don't do it because notes are very hard to de-identify. And there are some research papers that tries to automatically de-identify clinical notes so that it's like they can share it easily with researchers. But it's on the research. It's just the research staff. So there's no like commercialization as far as I know in that line. Okay, so one more time, don't share Mimic3. Okay, so tables of Mimic3. So there are 25 or 26 tables, if I remember correctly. This is EICU, so let's go to Mimic. Okay, so there's like 1, 2, 3, 4, about 10, 20, 24, 25 tables in Mimic3, and each table has different information, of course. And as I said, this is relational database. So that means that there are 25 tables in the hospital, in the Beth Israel Deaconess Hospital. They have 25 tables in their relational database. Not necessarily. I'm sorry, that's not technically correct. They might have different number of tables. It's just how the MIT engineers decided to dump the EHR, the raw EHR in the Beth Israel Hospital. They decided to. Sometimes the reason that this is Mimic 3 is because there's Mimic 1 and Mimic 2 now, and this is the third version. And as they evolve, they sometimes throw away information, they sometimes add more information, and they sometimes merge information from raw EHR. Like if there are two separate tables in Beth Israel Hospital which contains similar information, then the MIT engineers might merge them into the same table when they open source Mimic 3. So it doesn't mean that, it doesn't mean that the Beth Israel Hospital has the same number of tables as the number of tables in Mimic 3. So that was my mistake. It's not necessarily true. So, okay, so there are a lot of tables, and you don't need to go through all the tables, but some of them are important for creating a timeline. So the timeline meaning that this kind of timeline. So when we try to predict, for example, mortality prediction, what mortality prediction is, you want to predict whether the patient will die in the hospital when he's admitted. So to repeat in Korean, because admission, like all these medical jargons, so 그 mortality prediction이라는 게 결국은 죽는 거를 예측하는 거거든요. 이 환자가 이제 이 외래 환자랑 입원 환자랑 다른 타입인데, 이제 외래 환자는 저번에 말씀드렸듯이 그냥 한번 그날 와서 그 진단 받고 약 타서 끝나는 게 이제 외래 환자고, 이제 입원 환자는 그 병원에 이제 입원을 하는 거잖아요, 며칠간. 그럼 입원하는 순간에 이제 첫 뭐 12시간 아니면 첫 24시간의 어떤 그 기록을 보고 이 환자가 이 병원 내에서 이제 죽을지 안 죽을지를 예측하는 뭐 그런 것들이 굉장히 그 대표적인 EHR 가지고 할 수 있는 그거 그 뭐지 그 태스크 프리딕션 태스크거든요. 그래서 그런 걸 하려면 이제 이런 타임라인을 이제 그 구성을 해야 되는데, 요건 이제 외래 환자 타임라인이에요. So this is a outpatient record timeline because there are a lot of different number of encounters. So patient number ID 523 because it's all anonymized. This might be Mary, this could be John, but this is ID 523, and this patient has made at least three encounters over the past. So encounter ID 214, 351, 424. So it could be like outpatient encounter, inpatient encounter. We don't really know. But basically what you need to do is, in order to create a longitudinal, like time series record or like a temporal record of the patient's experience over a few years, you need to be able to reconstruct this this kind of graph by going over these tables. So I'll show you how to do that, like in today and maybe next class. So you can see that there's like encounters, and then each encounter has different diagnoses. Like if you go to hospital, the doctor might say, oh, you're here because of, well, I mean, the patient will say to the doctor, like, I'm here because of fatigue. I'm always tired. I cough. I have fever. I have stomach ache, and I have like pain in my chest. And then the doctor might say, okay, so you have these sets of diagnosis. And then for this and this, I'm going to give you Tylenol. And for this, I'm going to give you IV fluid like SWEC. So I'm going to give you IV fluid. And your abdominal pain and your chest pain probably requires some EKG, so I'm going to give you EKG. So, and these different types of information like medication order, procedure order, they're all in different tables. So you need to go through different tables and reconstruct the whole graph here. So for example, let's see, procedure. So encounter is the table that basically contains all the information when you are admitted to the hospital. So this admission table corresponds to the encounter table, which has like row ID, subject ID, admission ID, the time of admission, the time of discharge when you're released from the hospital. If they're dead, then the death time, how you're admitted, were you admitted by the emergency room, or did you just walk into the hospital? Like all kinds of information, So this corresponds to the encounter ID. I mean the encounter table. There's medication order table. There's procedure order table. For example, here there's I think there should be prescription. So prescription is where you order drugs. Prescription is the medication order. I think there's also procedure. So procedure is also here. So procedure order is here. Procedure order IDs. Procedures ICD. So a lot of different kinds of table. All right, so as I said, a lot of tables, and the thing that you should know before like analyzing or exploring each table is how the high-level structure of Mimic3 dataset is. So give me one moment. So I just talk alone for like 1.5 hours. It's just my throat is just raspy all the time. All right, so as I said, the Mimic3 is an ICU record, and the ICU being 중환자실. When you go to a hospital, you just don't go to ICU directly. You're not admitted to the ICU like directly from the moment they arrive to the hospital. 그러니까 중환자실을 병원에 오자마자 가는 게 아니잖아요. 일단 병원에 왔다가 이제 위험하면 중환자실을 가는 거잖아요. 그래서 중환자실을 들어가는 것과 병원에 입원하는 거는 다른 개념이에요. 미믹에서는. 실제로 다른 개념이고, 그래서 그거를 구분해야 돼요. So the being admitted to the hospital and being admitted to the ICU is a different thing. So that's what I'm going to show you in the next few slides. What I mean by that. So let's say, for example, there's patient 1, and this patient has 1 hospital admission in the entire Mimic data set. So let's say, for example, let's say this was a male. So I'm going to just refer to him as a he. So let's say he was admitted to the hospital. He walked into the hospital on January 2nd. And so that becomes your hospital admission event. And that is when this event is created. Like there's a row in this table will be created when this event happens on January 1st. So that's hospital admission. And let's say he was admitted to the ICU during the hospital admission on January 3rd. So this is the ICU admission event. And when this happens, a row will be created here in ICU stays. So ICU stays and admissions is a different thing. So the table purpose, it says defines each ICU stay ID, meaning that for a single ICU stay, there will be a row created in this database, in this table. So the thing that I want to emphasize, I want to clearly distinguish is ICU admission, hospital admission, different thing. So you go to hospital, and within the hospital duration, ICU admission might or might not happen. You might go to hospital and then you're admitted to the hospital, and then you get discharged the next day without any ICU admission event. Of course, that won't be included in the Mimic3 because Mimic3 is an ICU record. So you will never see, I don't think you'll ever see a patient who don't have ICU admission event, because Mimic3 is all about ICU records, but technically that can happen in real life. But in Mimic3, this is like a typical form this is like a typical pattern that you'll see in Mimic3. So it starts with the hospital admission, and one point during the hospital admission, there will be a ICU admission. So ICU admission followed by an ICU discharge. So when you're in a stable condition, you're no longer needed to stay in ICU admission. So then you'll be discharged from ICU and then return to your original ward, which 입원동. 그러니까 한국말로 얘기하자면은
이제 병원에 입원하셨다가 이제 굉장히 환자의 상태가 안 좋아지면 중환자실로 들어가잖아요. 그래서 중환자에서 며칠 있다가 이제 상태가 괜찮아지면 안정화되면 다시 입원 병동으로 돌아가거든요. 그러니까 일반 침상으로 돌아가는 거죠. 그게 이제 요 1월 10일에 해당하는 거, 요거에 해당하는 거, 요거. 이제 침상으로 돌아가는 게 이제 ICU에서 나가는 거니까 ICU 디스차지가 되는 거고, 그 다음에 하루 이틀 정도 뭐 더 병원에 있다가 이제 병원에서 나갈 수가 있는 거죠. 병원에서 아예 이제 퇴원을 하는 거죠. So you're returned back to your bed once you're stabilized, so you're no longer needed in the ICU, and then you might stay a day or two in your bed to see how you go. So they will monitor your situation, and then if they see you're good to go, they'll release you from the hospital completely. So that ends your hospital experience involving ICU admission. So that's one pattern that can happen. Another pattern is maybe so this is kind of a longer hospital admission. So one hospital admission, 2 ICU events. This could also happen. I mean, not just 2, maybe 3, maybe 4, maybe 5. It depends on your situation, how severe your situation is. But here, let's for example, let's say this patient number 2, he is admitted to the hospital on the 2nd of January, and then the first ICU admission happens on the 3rd of January. Get discharged at the 9th of January after a week, maybe a week. They stabilize, and then he is returned back to the hospital bed, and then stay there for 3 days, and then maybe something bad happens again to the patient number 2, goes back to the ICU, stays there for 3 days, and then get discharged again, and then stays in the bed for 2 days, and then and maybe the doctors are okay with the discharge, so they get discharged. So this can also happen. So 1 hospital admission, but 2 ICU admissions. So for this patient number 2, there will be 1 row in this table, admission table, but there will be 2 rows in ICU stays. So different pattern. And so this kind of information is important depending on your interest, your research interest. If you're interested in individual ICU events, then you can treat this patient you can treat these 2 ICU admissions as a separate event. I mean, depends on what you're interested, but you can treat them as a separate event. Like you wanna analyze what happened here, and you wanna analyze what happened here separately, independently. That might be okay, depending on your interest. But if your research focus is on the admission experience, then you need to consider the fact that there were two ICU admissions within 1 hospital admission. So there are certain things that you need to consider. And of course, I'm giving you all this because Mimic3 is an ICU record data set. Some data set might not have any ICU record. Some data set might be outpatient only. The claims data that I'm going to go over today, it's outpatient. Well, I mean, yeah, they don't have any ICU records. So in that case, like each encounter, each admission counts as just one event. So that's a different story. But at least in the ICU records, at least in Mimic3, you need to understand like this kind of thing could happen. Another thing, so the third pattern is a timeline, and maybe this patient has 2 hospital admissions, each having 1 ICU record. So first admission, 1 ICU record, 1 ICU admission, and then get discharged from the hospital. And then maybe a month or 2 later, maybe a year or 2 later, the same patient might go to the hospital for the second time, maybe for a different reason, maybe for the same reason. But this time again, get admitted to the hospital, and then get admitted to the ICU, get discharged. So this could be another pattern. So in this case, if you're interested in admissions, then you can treat these admissions separately. So that's another pattern. And not a lot of people are admitted to the so I said there are about 45,000 to 50,000 patients in Mimic3, and not a lot of people have 2 admission events, 2 hospital admission events. I think there are about 7,500 patients who has at least 2 hospital admissions. I think there are a lot of people who has multiple ICU admissions, multiple ICU being like you go to hospital once and then there could be like at least 2 or 3 ICU admissions, but this kind of pattern doesn't occur a lot in Mimic3. Like not like only 7,000, 8,000 people go to has at least 2 hospital admission events. All right, so another thing that is kind of important is the expiration event or the mortality event. Excuse me. All right, my throat is really sore. All right, so this what happens here is that this patient number 4 is admitted to the hospital, stays in the hospital bed for a couple of days, and then get admitted to the ICU because I don't know, he or she is like in a very bad condition, in a very severe state, stays in the ICU and then expires in the ICU. Expire meaning like expire is in medical terms dead. So the patient dies in the ICU, but which happens, as you can imagine, which happens a lot. So because if you're in ICU, that means you're in a bad condition, and like a lot of people could end up dying in the ICU bed. So this is what you're called expired event, and then you can see this thing. You can see this tag or label, and I'm not sure if it's in the ICU stays table. Let me see. Nope, not here, but it might be in. It's interesting. Why is it not here? ICU stays DV source first carrier and last carrier. Okay, it's not here, but it's definitely here in the admissions. So there's death time here in ICE admission. So death time being when the patient died. So if the patient died and when the patient died. If the patient didn't die, or if the hospital doesn't know if he died or if the patient died or not, then the death time would be null, like in your database record. But if the patient did die during the hospital admission, then there will be time recorded in this column in your admissions table. So you can infer whether this type of thing happened by by looking up this column in this table, in the admissions table. So yeah, so if you're aiming for mortality prediction, then this is a good application. I mean, this is kind of a too popular application because a lot of people do this. So I don't think there's any novelty in doing this task-wise, but it's a good practice to check the sanity of your model, basically. And if you use a lot of information, you can basically predict this in a very high accuracy. All right. Another thing I kind of forgot to mention is a very famous, very popular task is predicting the length of stay. So LOS meaning length of stay, which means that how long you're going to stay in the ICU bed. So in the first pattern here, so this patient was admitted to the ICU on the 3rd of January and then was discharged from the ICU on the 11th of January, meaning that this patient stayed in the ICU bed for 8 days. So 8 days is the length of stay. So you can that information will be recorded in this column. And like a popular task that people do is length of stay prediction. So when the patient is admitted to the ICU, not the hospital admission, but the ICU admission. So when the patient is admitted to the ICU bed, then your model might be able to see the first 12 hours, like 12 hours here, or maybe 24 hours worth of record, and then try to predict whether this patient, like how long this patient will stay in the ICU bed. So it could be like a regression task, like it could your model can actually predict, like output a number, like a scalar value, or it could be like a softmax classification, like you can have like different classes, like 1 day, 2 day, 3 day, 4 day, like more than 5 days, something like that, and then you do a softmax classification. So people do that actually. So like typical task they do is they do mortality task, as I've shown you here, mortality task, expiration, length of stay task. Another task is readmission. Readmission, like, there could be multiple definitions of readmission, but readmission task is basically So the hospitals in the United States get fined, get penalized for releasing the patient too early or prematurely, and the patient comes back to the hospital for the same disease. Like if the patient went under surgery for like cardiovascular, like heart problem, and then they went through a surgery, and then the hospital releases the patient, like confirming that the patient is like completely healed, and then if the patient comes back to the hospital for the same heart related problem within like, I don't know, within a month, then that means that the hospital didn't do a good job in the first place. So the government will penalize the hospital for not doing a good job. So hospitals are very, very careful about this readmission event. So because they end up paying a lot of like penalty, like they end up paying a lot of money for that. So readmission prediction is a very like big task. When they are about to discharge a patient from the hospital, like they can have like a predictive, like readmission prediction model run the record and see if that predicts predicts whether this patient will, if the patient will come back to the hospital for the same reason within like a certain amount, like within a month or within 2 weeks, with high risk or like high probability that they might do things a bit differently. So readmission is like a very popular test. So mortality prediction, readmission prediction, length of stay prediction, maybe like disease prediction is also a very popular task. So these tasks are what Google did when they released the 2018 paper. Let me just show you the Google paper, Scalable and Accurate Deep Learning with Electronic Health Records. Download PDF. All right, so this, this is the paper that came out from Google, formerly Google Medical Brain, now Google Health, which is the team that I was in like a month ago. So what they did is they did, I think they did 4 tasks in total. Here, yeah. So they did inpatient mortality, being like whether the patient will die when they're admitted. So this is expiration prediction or mortality prediction. So they did inpatient mortality. They did 30-day readmission. As I said, if the patient comes back to the hospital within 30 days, that's a penalty for the hospital. So 30-day readmission. Lengths of stay at least 7 days. So I guess this is binary task. So when the patient is admitted to the hospital, not necessarily admitted to the ICU, because this paper was not based on mimicry. This paper was based on Chicago University of Chicago Medicine and UCSF, University of California, San Francisco. So this paper was based on those two data sets from 2 hospitals. So this is not about mimicry. So length of stay. So when the patient was admitted to the hospital, what Google did is they predicted whether the patient will stay in the hospital for at least a week or not. So it's a binary task. And another final task is discharge diagnosis. So when the patient is released from the hospital, they are given certain set of like diagnoses, like a list of diseases that you were in the hospital for billing purposes. So when you're released from the hospital, they will write up a report or a list, like this patient Edward Choi was in the hospital for 7 days because of like cough, fever, stomach ache, and whatever, like a list of symptoms. So, and there are certain interests for being able to predict that before, so that the hospital can adjust to the needs of the patient. So they did 4 things: inpatient mortality, 30-day readmission, lengths of stay, discharge diagnoses. And this is a very typical task. A lot of people do that, but with different definitions, basically. All right, any questions so far? Or anybody want? Okay, please go ahead.
Professor, I think it's a little bit late to ask, but I have a question about the MXC data. So you say, as far as I understand, so we modified the data to not able to specify the person, right?
Oh yeah, the identification process, yes.
So, but what I'm wondering about is, so there's some disease like some kind of seasonal disease like I say the current issues, the tuberculosis or some kind of pneumonia.
Yeah.
So so if the data is modified depend on patient, not the disease. So in the case, maybe in some cases, like if I got a pneumonia, but my symptoms is called the pneumonia, but I want to make it specify more clear. I want to make it more clear, but my machine learning model doesn't care about the seasonal data of disease, so it can be considered in our model, but I think the mimic3 data is not able to make some kind of model like that.
Let me see if I understood your question correctly. So
Yeah.
so you're interested in you're interested in seasonal diseases, but you want no could you repeat that question one more time? So
I think you got what I asked. There's some seasonal disease, but mimic3 data is modified the date of event.
Right. But as I said, But as I
So,
said,
but
they don't change it too drastically so that the seasonality is preserved. So they preserve the time of day, which is the hour, the day of week, which is like Monday or Tuesday, whatever. And seasonality is like summer, winter, fall things. So if you're interested in seasonal diseases like flu, for example, then at least you will be able to, you won't be able to precisely calculate based on Mimic3 because they will shift like at least within the same seasonal, like same season, like within the same summer frame. Like I don't know what the frame is basically. For example, I don't know if they set the frame of summer to June to August or maybe July to September. I'm not sure how they did that, but at least you'll be able to see like certain diseases like flu will be more popular in the time frame of like September, August, or November. I think that much will be guaranteed with Mimic3.
Okay, thanks.
Okay, is that what you wanted to ask? Did I answer your question correctly?
This is the other one.
Okay, cool. All right. Just to be clear, Mimic3 is not a great data set for seasonal analysis, to be honest, because it's an ICU record. It's not a longitudinal record, meaning that longitudinal meaning like it doesn't span over like several years. So as I said, in order to be able to see the seasonal pattern of diseases, you need access to like a nationwide claims data, like insurance data, because insurance data I'll get to that later. I'll get to the seasonal analysis after I go through the Mimic3. We have like 10, 15 minutes. I'm not sure if I can do that today, but still, I'll try to make it work. All right. So, so this is the end of the patient admission patterns, and then the table sources. So as I said, there were 24 or 5-ish tables in Mimic3, and some tables are related to the hospital admissions, and some tables are related to the ICU events. And so this is this page talks about that. So admission related tables are these. So of course, admission table itself will be about incorporating the admission duration. Call out is about, it's not really, I'm not sure if it's important, but the call out is about like the hospital is, when the hospital is ready to discharge a patient, they'll have like a flag or like a checkbox, like this patient is ready to be discharged, and then that will be recorded in the call out. CPT events is about, CPT is a coding system for procedures like IV fluid, X-rays, or having a cast, like a kipsu, having cast, or what else, like EKG or EEG, like MRI. That they are all like procedures, and each procedure has a code, like integer, and they follow a certain system. Like the system is called CPT. So CPT has like thousands of codes describing different set of procedures. So I think I have opened a CPT. So yeah, CPT is a current procedural terminology. I'm not sure if there's a Okay, so there's no example, but CPT typically starts with like a P or E, or like it's a bunch of numbers, and then each number corresponds to like a specific procedure, like CPT code E1567 corresponds to like IV fluid. It's basically something like that. So CPT events meaning like a certain procedure was ordered, and diagnosis is ICD. So ICD is I'm not sure if maybe some people are familiar with ICD, but ICD is a coding system for diseases diagnoses. So CPT is a coding system for procedures. ICD is a coding system for diagnoses. So so this is ICD-9. So ICD has like versions, just like Mimic3 has versions. So there's ICD probably 1, like way back. Now ICD-9 is a 9th revision. There's ICD-10. So hospitals are recommended to use ICD-10 these days, but Mimic3 uses ICD-9. So ICD-9 is a hierarchical structure. So on the very surface, there's like an abstract general category. So like infectious and parasitic disease, neoplasm meaning like cancer, endocrine, nutritional, like different categories, mental disorders, whatever. And then if you click one of these, then you go into subcategory, and then there's like different types of cancer, like benign cancer, cancer of genitourinary organs, cancer of bones, cancer of the lips, digestive organs, like different types of cancer. And then if you click, let's go into respiratory, which can be like lung cancer. So in this subcategory, there's bronchus, so like something related to your lung, nasal cavity, your like nose area, larynx, your throat area. So different types of cancer. And then if you go into the lung cancer category, there will be subcategories. So this is the final category. So 162.0 is trachea. That's, I don't know what you call it in Korean. Main bronchus, upper lobe, like different types of lung cancer, like lower lung cancer, upper lung cancer, different types of lung cancer with like 5-digit or 4-digit codes. So if you click this, you have a pretty accurate description of what it is. Like this is a medical code that is whatever, like say blah 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 blah. So ICD is a diagnosis code. So just like CPT events, you throughout your admission, your diagnosis will be recorded, just like discharge diagnosis here that I showed you in this paper. Discharge diagnosis, they also use ICD. So a lot of people use ICD. So yeah, so basically there are a lot of tape. I can't go through all of them one by one, but maybe once you have access to the CSV files, we can go through some of them to see how you can reconstruct that graphical structure. All right, so that's it. And the ICU related. So these are tables that are related on the admission level. The hospital level. These are the the tables that are related that involved in the ICU level. So chart events. Chart is when you're in the ICU bed. There's a chart hanging in your bed, like a chart, and then the nurses or the doctors will attend to you maybe every hour, maybe every 2 hours, and then they'll record what your status, like stable breathing, or like stable blood pressure, or the color of your urine, a lot of things. So it'll be charted every single hour or every single couple of hours, and then that can be your clinical note, basically. So chart event, Mimic3 is about 6 gigabytes of data, and 4 gigabytes of data comes from chart events. So this is where a lot of information is hidden. Daytime event, anything that is related to dates or times is all hidden here. The thing about Mimic3 is that the Beth Israel Hospital changed from one EHR solution or one EHR program to another in the like 2008 or something. So before 2008, they used a program called CareVision. I'm not sure which comes first. Let me see. It's all here somewhere, like data details and stuff. So okay, CareView and MetaVision. So CareView. Okay, so CareView system is a program that the Mimic3, the battery result used between 2001 and 2008. After 2008, up till now, like 2020, they're using a program called MetaVision, and they have different schema because this is different database. They have different schemas. So the MIT people gone through a lot of trouble to merge the information from two different schemas into a single unified tables of Mimic3. So, and some were mergeable, some were not, like because they're different schemas. So some were like unifiable and some were not. So that's why there's a table, different tables sometimes called input events CareVision and input events MetaView. Where MetaView? No, input events CareView and input events MetaVision. So here there are two different input events. Basically, input events is anything that goes into your body when you're in your ICU bed, like IV fluid or painkillers, 진통제 painkillers, or certain types of drugs are like continuously put into your body system, but through your vein, like so that is all recorded in input events. And apparently CareView and MetaVision used the schemas so different they were not mergeable into a single table. So that's why MIT people ended up just open sourcing with two different tables, one in CareVision and one in CareView, one in MetaVision. Note events is free clinical notes. Output events is something that came out of your body, like your urines or I don't know, your bloods, something like that. All right, so procedure events is procedures, just like CPT, like doing like lab tests, like measuring your blood pressure, measuring the allergenic reactions, your urine related measures or scalar values, that kind of stuff. And if you're interested in different types of coding systems, so CPT, as I said, is so anything that start with a capital letter D is a definition table. So when you go through a lot of items in Mimic3, they use a lot of codes like CPT codes, ICD codes. ICD is different. ICD is diagnosis and procedure codes. So ICD diagnosis, ICD procedure, item codes, lab item codes. And you might wonder what they mean. Then you should go to these tables, the tables that start with capital D. All right, so I'm not sure if you have access to these. So do you need to be able? Do you need to be? Okay, I don't think you need to have access to Mimic3 in order to see the schemas, but it is pretty useful. So when you click that, when you go to this website, which also you can go through by data details here. So you click data details and there's schema, and then you click this, then you'll be led to this website. And so there, as I said, there are it says there are 40 tables, but this is because they've like divided chart events into 14, 15 different chart events. As I said, chart events takes up like 4 gigabytes out of 6 gigabytes of Mimic3. So chart event there are 40 tables because they divided into 15 different tables. But you see the definition tables, you see CPT events, caregiver chart events, a lot of, and then you can, when you click one of these, like for example, when you go to patient, then you can see which one is primary key, which is like foreign key, and all that. And the primary key of patient will be used in these child tables. So there's a very nice schema, and you can see how all these information is related, like used in different tables. So patient is like the one sitting at the very top. There are like 25 different tables. Patient sits at the very top, and then the subject ID or the patient ID will be used throughout a lot of tables. And you can see like admission table uses subject ID as a foreign key. So you can see foreign key, the patient ID, subject ID is coming from the patient, and then the admission ID, which is the primary key of admission table, will be used in a lot of different children as well. So like so here admission table. The admission ID will be used in the ICU stays, lab events, microbiology event, note events, like a lot of different a lot of different events. So if you're interested in how all these keys are related to each other, like schema is a nice interface for you to look at. And then there's a SQL, there's a place where you can like do a simple SQL query, because this is a relational database. You can do SQL query. Okay, so for this you need to be, yeah, of course, because you're accessing when you're doing SQL query on Mimic3, you're accessing the patient records. So you need to be a member. You need to have access to the Mimic3 database. But for the schemas you don't need to. But for these you need to be a member of Mimic3. So let me just show you a demo. Come on. Oh, okay. I'm sorry. All right, we only got 3 minutes, so I guess we'll have to wait for the claims data and the seasonal analysis for the next class. So here I can just say select something, select all from patient table, limit 1, and then maybe it was patients. All right, see, okay. So so just a random row from the patients table. So row ID 234 and subject ID. So row ID doesn't correspond with the subject ID. Subject ID is the ID given to the patient uniquely. Row ID is just that this means this is the 234th row of the patient table. So this patient ID 249 is a female, birth date 2075. So which is like because of the random shift. And the date of death, they don't know if the person died or not, so they just say none. This is null value. Date of death in hospital, so they don't know if the patient didn't die in the hospital. That's why it's none. And social security. So in the United States, just like SSN, social security number is like the 주민번호 in Korean, a Korean system. So if the hospital knows that, depend by the social security number information whether the patient died or not, in that case, if they know, then they'll record something here. But in this case, they don't know if the patient died. So no. So expire flag, whether the patient died or not, is 0. Let's do it one more time. So okay, so maybe I can do select everything from patient, where I'll just do it in all lower cases in case. All right, where subject ID is 250. Okay, fortunately I got it right. So this person died in the hospital. So so when Mimic3 uses this means that the patient didn't die in the hospital, so they track the record of the social security number so that they want to know if the patient died or not after the discharge. So, but in this case, the patient did die in the hospital, pretty young. So date of birth was 2164, but died at 2188 at the age of 24. So pretty early. Female, expire flag 1 because this patient did die in the hospital. So all right. So basically, you can do this. Maybe we can do. Okay, so we're out of time. So maybe you can just one last. So okay, Korean national insurance claims data. So that'll be the next time. So one final note: you can't do this now because you don't have access to Mimic3. They said you need to wait for 2 weeks, but you can do this by installing a Postgresql locally. So when you download the CSV files by the link that I'm going to share on Classroom and KLMS, you can download the CSV files, and then you can install your whatever MySQL or PostgreSQL locally, and then upload the CSV files you downloaded to that database, and then start querying. You can do the same thing. It's just that here they're doing it for you. In local, you can install your own SQL database and then do the same thing. So if you're interested in do that, please do that. It's a nice way of exploring the data. All right. So okay. In summary, if any, so 1 or 2 people who didn't request access to Mimic3, please do, and then so that I can share data to you. yeah, and then please download the Mimic3 data sets I'm gonna share after this class, and then please keep track of KLMS in class, and I'll see you guys next time. Yeah, sorry. I mean, sorry for taking too long, and I'll see you next time. Thank you very much.